Here we'll look at lesson 35, which you'll see here we'll look at a few different topics or concepts with integrals. So constants, a constant times a function, and then x to a power. So let's just jump right in. How would you anti-differentiate a constant or integrate a constant? Well, we've been thinking the derivative of what equals 4, and we know to get a constant here, to get a 4, we need a 4x. We put x because it's in terms of x here, so this would be 4x plus c. To get a pi, and we could check this, we could take the derivative of this. 1 comes out front, 4 times 1, and then x to the 0, so this is correct. Here, pi, to get a pi, we would need a pi times a variable. In this case, it's t, so pi t plus c. And again, you could check, this is a 1. So the 1 would come out front, and you would have a t to 0. And so it looks like we're going to just be having the constant times the variable that we're integrating in terms of, plus c. So here's the concept. Integral of a constant is just going to be k, constant, times the variable that we're working with, plus c. Nice and simple. Next one, what if a constant is multiplied by a function? So we have maybe 10 times a function, maybe sine of x. So we remember that when we differentiate a constant times a function, the constant just stays with it. Therefore, we can just move the constant to the left of the integral. So if you have a constant times a function, you can put the constant on the outside, and it's just going to come along with it. So here's one. We have the integral of 4 cosine of t. Well, the 4 can just come out here. And we want the cosine of t dt. Well, we know that cosine, the integral of cosine is negative sine. So not negative sine of t plus c, and then we write it as negative 4 sine of t plus c. That's incorrect. Sorry, the integral is positive sine. I was thinking backwards there. So this is positive. But here we will have a negative. So integral of sine of u. Well, we don't have anything that gives us the derivative of cosine is negative sine. So we're going to have to say negative cosine of u plus c, and the integral of cosine is negative sine, negative sine. So that is correct. Sorry about that mistake over here. Integrate the following. So we're going to think through here. If we had an x squared, we would have needed an x cubed to take the derivative of. And plus c, so we check that, 3x squared plus c. Okay, so that works. Well, this time, instead of having a 3 out here, we don't have anything, so we know we need an x cubed. But x cubed, take the derivative of that, you would get 3x squared. And we don't want a 3x squared. We need just an x squared. So what we do is we fix our original, and we put 1/3. And now when the 3 comes out, this would cancel, and you get the correct answer. Looking at the next one, the derivative of what would give us x to the 6th? Well, something to the 7th. And if we check that, we would get 1/7 x to the 6th, which here we have the x to the 6th, but we have this 1/7 here, so we have to correct this So multiplying by 7 would fix this. 7 would come out front. And there you go. That would be that answer. 1/2. Now this one's a little trickier. This is x to the 1/2. I don't know if it's real clear with the typing here. So this is x to the 1/2 dx. Well, in order to get a 1/2, we would have to subtract 1 from something. So we know this is x to the 3/2 plus c. But if we took the derivative of this, the 3/2 would come out front, and we would have x to the 1/2. So the x to the 1/2 is correct, but this is not correct. So how do we get rid of this? Well, we would have to come up here. Now we have an extra factor. We have an extra factor of 3/2. We don't want a 3/2. So we multiply here by the reciprocal. And so for x to the n, we're going to try to come up with a general idea here. We need 1 above this, but then we need the reciprocal of this, so 1 over n plus 1, which can be written in different ways, but here we have it, x to the n plus 1 over n plus 1, and I forgot a plus c over here. So here's the general rule for integrating a variable to a power. The variable goes up, the exponent goes up by 1 and then divided by n plus 1, or you could have a fraction out front. This means the reciprocal of n plus 1. So we can hurry through a couple of these if we know this rule. So the 5 comes along for the ride, and then we'll have s to the n plus 1. Negative 20 plus 1 is negative 19. And this needs to be over 19 plus c. So better yet, this would be 5/19 negative 19 s to the negative 19. This one we'll want to rewrite. The 1/3 can come to the outside, and then we're going to integrate. This is actually just t to the 2/3 dt. And so we integrate, the 1/3 comes along. We get t. We add 1 to this, which is really like adding 3/3, so t to the 5/3. But then we have to do over 5/3 or multiply by the reciprocal. And so in this case, the 3's cancel, and we get 1/5 t to the 5/3 plus c. Over here, more of the same. We can bring the 3 out. U to the 1/2 in the denominator is u to the negative 1/2 in the numerator, du. And so the 3 stays here. We go up 1, so u to the 1/2. And out here, you do the reciprocal of 1/2, which is 2. And then plus c. So this one we just get 6u to the 1/2 plus c. And the last one for these examples, the 5 can come out front. And then this would be z, and now this is irrational, so we just have to write it as pi minus 1, pi plus 1, which means we need a pi plus 1 in the denominator or fraction here, pi plus 1 plus c. And cleaning this up, looks like we could write it as 5 z to the pi plus 1 all over pi plus 1 plus c, of course. And there you have that one. So we have a rule for that. Our last one here, we have a couple special cases, or actually one specific special case, and we have two examples for it. We have x to the minus 1 here. If we tried to follow our rule, it would be x to the 0, because we add 1, and then 1 over 0, which is undefined. So that obviously does not work. So when we have an x to the negative 1, we remember this is like the integral of 1 over x dx. And we know the derivative of something that gives us 1 over x, and this is natural log of the absolute value of x plus c. So if we have x to the negative 1, or if we have x the first in the denominator, we know it has to do with natural log. So this one just uses the rule we learned today. The 3 can come out here, and then we're doing integral of 1 over x dx. Well, this is 3 times the natural log of the absolute value of x plus c. And the last thing I want to mention, just like derivatives, you can split up an integral of a sum into the sum of the separate integrals. So when we want to take the integral of a long sum here, we just do the integral of the individual parts. I'll write it out the first time here, although, so this is going to be, this is really what we're doing, the integral of 5s ds s plus 3e to the s ds plus, I forgot the integral, and plus the integral of 4 ds. So really we just have to integrate each individual term. So using our rules here, this would be s to the 13th, and then 6 over 13, plus the integral here, this would be s squared, and we would have a 2, that's the denominator, so 5 halves, plus this is an e to the s, so it just remains e to the s with the 3 out front. And then lastly, it's a constant, so plus 4s, and then plus c. Another one, the derivative of what gives us sine? Well, the derivative of cosine gives us negative sine, so this would be negative 6 cosine u, plus this one goes up 1, so that would be u to the negative 4th, and then it would be 5 over negative 4, plus we have this again, 3e to the u, minus, this is a constant, so it would be minus 2u plus c, and there is our answer for that one.